I will talk about some results on minimal Liouville gravity. In fact, this works continuation of the last work Dima Knizhnik, which was he began just before his passing away. Then it was finished by Sasha Zamolodchikov and Sasha Polyakov, and it is very well-known work Knizhnik, Polyakov, Zamolodchikov, and I will talk about some continuation, so to say, this work. So this minimal, so-called minimal Liouville gravity is was invented and partly solved by Dima Knizhnik, Polyakov, and Zamolodchikov in 1987, and it is a very important case of so-called non-critical string Polyakov string theory. And in this case, it's also an example of Liouville gravity. In this case, the matter sector is one of minimal models of conformal field theory. And in the problem which was open after this first work was finding of correlation functions in this theory, even for genus 0. It's a difficult problem because we need to calculate some integral over modular space of Riemann surfaces with endpoints, and the observables are some special combination of fields of minimal minimal model of conformal field theory and Liouville theory, and in fact only it was solved. It's a difficult problem because we need to integrate over modular space of Riemann surfaces. Some progress was achieved in about 8 years ago due to the work results of Alyosha Zamolodchikov on high equation of Liouville field theory, and in our joint work with Alyosha, we computed 4-point correlation function, which is the first case when we need to integrate over modular space. But to compute other correlation functions, it's still open problem. And we, instead of computing of correlation function, in fact, it's not correlation function, it's correlation numbers, because it doesn't depend on the position of the field because of integration. We can compute the generating function of these correlation numbers, which is defined like vacuum expectation value of exponent, this exponent, and its derivatives when a coupling constant lambda equal 0 is nothing but correlation numbers. This coupling constant lambda can be considered as a coordinate on the space of perturbed minimal gravity, Liouville gravity theories. And another, it was in this approach we try to compute these numbers by direct calculation of integral over modular space. Another discrete approach to two-dimensional gravity was invented by many people like Kozakov, Migdal, Kostov, Staudacher, Brezan, Douglas, Schenker, Gross. And in this approach, which is realized by integral over through matrix models, we describe fluctuating two-dimensional surfaces like ensemble of graphs, and in continuous limit we expect that this two approach give the same result near critical point. And in Douglas in the end of 80s discovered that the partition function in this matrix model approach satisfied to so-called string equation, also KdV equations, and the KdV times parameters of in KdV approach Tmn for KdV case for Gelfand decay generalization plays the role of perturbation parameters lambda in minimal level gravity. And Douglas found that these dimensions, gravitational dimensions of these two sets of parameters in Liouville approach and in matrix model approach coincide. However, attempts to compare correlation numbers itself, not only gravitational dimensions, showed that naive identification doesn't work, and this is the problem. In minimal Liouville gravity, we have select a set of selection rules for correlation functions or correlation numbers, which are inherited from selection rules, conformal and fusion selection rules of minimal model of conformal field theory. Say 1-point function should be equal 0, 2-point function should be diagonal, and then we have other selection rules, fusion. So we have some restriction for if we compute correlation numbers of Liouville field theory, we have some restrictions for this correlators. So how to reach? The problem is how to. Is it possible to use Douglas approach to? I mean, it's possible to conjecture that the correlation numbers and the generating function satisfy to Douglas string equation, but correlation numbers are based the restrictions from minimal, which follow from minimal model of conformal field theory. The idea to reach this fulfillment of the selection rules is the following. It was suggested, the solution was suggested many years ago by Sasha Zamolodchikov, Mohr, Zyberg, and Staudacher. When we compute a correlation numbers in Liouville field theory, we have to integrate over modular space, and we met the problem of contact terms. And it is equivalent that the statement that there exists some non-trivial relation between natural between KdV times, which are natural variables in KdV approach, and Compline constant Liouville field theory. Liouville minimal gravity, in which selection rules naturally are fulfilled, and because of this contact terms, these variables whose gravitational dimensions are equal. Dimensions are equal, cannot coincide themselves, but has some additional terms. And in the appropriate choice of such change of these variables allowed this author, more Zyberg and Stadacher, to reach coincidence for 1 and 2 point correlation numbers in Lie-Yang series of minimal gravities. But then, when after 4 point correlation function had been calculated, it became possible to make new explicit check against Douglas equation approach, and it was performed for the same series, Lie-Yang series of minimal gravity, in our work with Sasha Zamolodchikov, and the full correspondence between Douglas equation idea of such kind change of variables the coincidence was reached. The aim of the following work, which was done with Dubrovin and Muhamedjanov, was generalize this result and check that it works also for other cases of models of minimal Liouville gravity. And analysis is based on the following assumption. The first assumption is that there exists in the space of perturbed minimal Liouville gravity, there exists such special coordinates Tmn, which doesn't coincide with natural lambda mn, in which a partition function of minimal Liouville gravity satisfies Douglas string equation like it does in matrix models. Then the next assumption is the string equation define this string, there exists this coordinate, and this from partition function or generated function of correlation numbers is nothing but logarithm of theta tau function for the dispersionless generalized KdV hierarchy. KdV or Gelfand-Dickert hierarchy with some special initial conditions which defined by Douglas string equation itself, because Douglas string equation is not identical to KdV hierarchy, but it includes also some impose some restriction for initial condition. The next assumption that that KdV times T Mn related with natural coordinates lambda Mn on the space of perturbed minimal Liouville gravities by some nonlinear transformation. And we established the form of this transformation from the requirement that correlation numbers should satisfy the selection rules which are in minimal models of conformal field theory. And plus, it was very useful that we use some very convenient expression for partition function of minimal Liouville gravity. We use to get this explicit formula. We use some relation between Douglas string equation and the structure, Frobenius structure, which is connected with this equation. Okay, let me put some details. Minimal Liouville gravity consists of Liouville field theory, field phi, and some meta sector. In our case, it will be one of the models of Coupe, a minimal model of conformal field theory. In this model, we have the set of primary fields and which is called phi Mn, which is enumerated by nodes of Katz table, and we consider these two series, Li-Yang series and the next one. In this series, Katz table consists of one or two rows, and we can choose this field due to the set of primary field, and we have the following restriction for operator product expansion, fusion rules for operator product expansion, which is written here, and we will use this restriction. From projective invariance, we have for the genus 0 also that 1 point correlation function is 0, 2 point is diagonal if dimension of the field in meta sector do not coincide. And for higher correlation numbers, we use fusion rules for operator product expansion, and together with these two rules, the result we get some restrictions which is written here, such kind. Okay, now the gravitational sector in Polyakov approach is defined through path integral over two-dimensional Riemann matrix, and in conformal gauge we have it's described by Liouville field with this action, and central charge of it is conformal field theory, also Liouville field theory with central charge is connected with with coupling constant B, like it's written in these relations. And to define minimal Liouville gravity, we have to suggest that the central charge is in meta sector and Liouville sector. Their sum is equal to 26. and from here we get this value for coupling constant. Okay, observables in minimal Liouville gravity are homologies of operated by RST operator, and for the simplest observables looks like it's written here. They are integral over our surface, and OMN is integrand is product of field, primary field of matter sector and exponential field in Liouville field sector, and it is should be a 1-1 form, and from here we get this value for so-called gravitational dimensions. It depends on the field phi, observables Mn, and from the model Pico. These operators have the gravitational dimensions in terms of cosmological constant mu, like this, and they satisfy the same selection rules like fields phi Mn from matter sector. It is definition of correlation number, and this is their generating function. Because since to compute correlation numbers we should integrate over two-dimensional surface, we get the problem of the following. We meet the following problem when two or more points in this integrand are coincide. The contribution of such situation are not controlled by conformal field theory, and we can add contact delta-like contact terms, delta-like contact terms. And this ambiguity is equivalent to possibility to add to correlation number some another correlation number of different order. This contact terms also equivalent on the language of coupling constant to adding to such kind such variables lambda. Such terms correspond to some contact delta like term, and so any addition of contact terms equivalent such change of variables. We can restrict this change from dimension consideration. We can impose restrictions that only such terms in this sum we can have, which has the same gravitational relations as the lambda Mn. It means that we can restrict it, imposing this relation for terms only such C, constant C, are not equal 0 if this relation is fulfilled. But however, it's not exclude such change, because in minimal model we have minimal Liouville model we have, because gravitational dimensions are some rational numbers, we have a lot of relation of such kind. So there exists different system of coordinates lambda, and in general minimal Liouville gravity and Douglas and variables in Douglas approach do not coincide. And we can use this freedom to try to fulfill selection rules for of minimal Liouville gravity. So we will do in the following way. First, we will estimate of free energy or partition function, generating function of correlation of numbers from Douglas equation, and then we will choose such change of variables that selection rules would be satisfied. There exists explicit formula for 3-point and 4-point correlation numbers in minimal Liouville gravity. And in 3-point function, it's useful to normalize this 3-point function in the following way, such to do it not dependent of the normalization. And it gives us possibility to compare correlators in Liouville, minimal Liouville gravity, and in another approach, comparing such correlations which do not depend of the normalization. So for this, for normalized 3-point function, we have this formula, and for 4-point function we have this formula, which was calculated by in our work with Alyosha Zamolodchikov using his high equation of motion in Liouville field theory, explicit formula, and we will try to find this contact term in such a way to fulfill selection rules first, but then we will compare also this 3- and 4-point function where we can do it, because in one approach, from Douglas string equation, we can get any correlation function in principle, but we don't know how to get up to now 5 and more point function in a direct approach. And doing this, we will use selection rules. In Douglas approach, partition function of QP minimal gravity is described as follows. We take two differential operators, P and Q. Q is differential operator of Q small order. U alpha of X is some coefficients of this differential operator, which depends of variable X and also of times, KdV times. And P is the second operator, which is defined as a positive part of the pseudo differential operator, which is defined in the brackets. And T, K alpha are KdV times. It means that if we fulfill this is Douglas equation, P is equals 0, and it follows also that if we define from this equation the coefficients U1, say, and U2 and others, they will depend of the times. They will obey. Evolution equation, usual evolution KdV equation. But this equation contains additional information about initial condition for our coefficient U alpha. And instead of using this equation, because we are interested in genus 0, we can take quasi-classical limit and consider, instead of commutator, Poisson bracket PQ, which defined like this. And instead of operator Q and P, we can consider their symbol. So we have Poisson bracket of two function of variable P. P is symbol differential operator D. We have this polynomial. It's already polynomial of variable P. Q order. Don't miss. Sorry, P is not the same number which is in definition of minimal real gravity. And we have to solve this this equation. Poisson bracket PQ is equal to 1. This equation is equivalent to the following action, so to say, list action principle of the list action, which can be written like this. S is nothing but residual in point when P is goes to infinity of this polynomial. With this Laurent polynomial. And this is denotation. C alpha is residue of this degree of polynomial, not integer degree. Now we want to ask to find which the terms which we should include in this definition. To do this, we should do some dimensional analysis. I will skip it, and in result we get the following identification of the dimensions. It's written above. Our times down t k alpha is should has it's better. We will numerate. We will numerate this like tmn should has. I will. Let me skip this details. This is the result. If we leave only the finite number terms, which is written here, we have this degrees of our polynomial Q. Then variables Tmn will have the same dimensions. Gravitational dimensions as gravitational dimensions of Liouville variables. Okay, now these variables and lambda variables in Liouville connected. We will suggest that they connected by such kind relation, and each term in the right-hand side has the same scaling dimension like this one. So there exists some, not so many, but there exists some terms. It is polynomial. In fact, it's polynomial of lambda, the right-hand side. And now to Now we will try to satisfy the selection rules, and for this it's useful it's convenient to use the following expression for generating function. In Douglas approach, generating function connected with solution U1 star solution of string equation like this. But it's possible to write more explicit formula, which is useful for the following analysis. To do this, we use this connection between string equation and Rabinian structure connected with it. Let R is algebra of polynomials modulo Q prime. Q is our polynomial, which is connected with given series of models. So we have in this approach naturally we have a series of minimal models instead of PQ. We use the following nomenclature. Here K is integer part of this ratio P0 остаток, как сказать? Остаток. Reminder, yes. P0. So P0 is and all this series connected with polynomials Q of sorry P, not this one, which is, let me, like Y. And this is the definition of our algebra. It's our algebra of polynomials model Q prime. Q prime is derivative. So we can define also bilinear form on the space of such polynomials, which is written here. Here is residue, and we can introduce some bases in our algebra, and C alpha beta gamma is a structure constant of our algebra, which is connected with this bilinear form G big gamma, and this tensor C alpha beta gamma like this, and then we can then the statement is the following, that the solution of this equation, this relation, we can solve, so to say, this relation between the partition function f and solution of string equation, and write this formula. Here we have this tensor, which is obtained. We got from structure constant of our algebra. We can compute structure constant and get this. Is this tensor, and S is nothing but action, which I wrote before. let me show where is action. This one. This one. So we have this formula for partition functions, for generating function. First of all, it should we have this integral integral over d u alpha, and this integral should not depend on the path. It means that this one form, differential one form, should be closed. And also we should check that this Douglas relation of this form, such defined by this formula, partition function and solution of our equation fulfilled. We need to have this to check that this one form is closed. We need these two equations. It's nothing but associativity requirement for associativity of our algebra, and also this recursive relation, which for residues of different order, which can be checked that they fulfilled. And so we have explicit expression for partition function, and we make some admissible change of variables from KdV to lambda, and we'll find simultaneously the form of this substitution and correlation numbers step by step, 1 point, 2 point, 3 point, and so on. Consider a simple example this case when it's KdV, in fact, case or Lie series of minimal Liouville gravities. And in this case, we have our polynomial is the second order. We have a very simple form for our generating function. Su, the Su is such polynomials of the only variables U. It's written here, and we have. I use here somehow the enumeration of variables t of times, and then we should to get a generating function for correlation numbers. First, we insert this resonance transformation. After this, we have our function. Generating function like some polynomials of variables lambda, series, in fact, variables lambda, and S is polynomial of lambda. Also, our action, derivative of action of these variables. And then we all these polynomials looks like this, like polynomials of the variables U, which has some dimension, cosmological constant mu, who also has dimension, and some numbers B, C, and so on, which are parameters of our resonance transformation. And we should find them from our selection rules. We have some selection rules, which is written here. It's some convenient switch of two dimensionless variables, and we have such formula for our partition partition function, and the upper limit x star is solution of string equation. It means that it's 0 of our function y u, and from dimensional analysis we can understood that our function y0 and yk has some polynomials of some order, and then they go polynomials which includes degrees of x with step 2. Therefore, it's convenient to use such change of variables, variables x. We get our another set of variables which now are function of y, new variable y, and we get for 1 point in 2 point correlation numbers, which we get above from our definition of partition function. We get the following to explicit formula, and it is 1 point function, and it should be equal 0 when k is not 0. And this is 2 point function. It should be 0 when k1 and k2 are not equal. And from dimensional analysis, we know the order of these polynomials and this one and this one. And I will skip this. It's very simple. Think we can we arrive to this following statement looking in this to this requirement which follows for our selection rules. 1 point function should be equal 0, 2 point function should be. We arrive to the statement that yk is nothing but Jacobi polynomials of such form, which the result is summed in this table. We get this it's Jacobian polynomials of this order, like this one, say, with how it is called. Нет, это функции, которые. Как? Нет, я имею в виду. We define Jacobi polynomials as как? Kernel, probably yes. I remind denotation. Measure probably, yes. Yeah. So it should be 0 if n not equal m, and okay. So we arrive to this statement. We can do it. It is done in general, in the way which can be used in general case, also for other series. But namely for this series, Lie series, we could use another way of doing, and we arrived. It was done in our work with Sasha, and we arrived to Legendre polynomials. But Legendre polynomials connected with Jacobi polynomials like this, in this case. And then we do it the same for 3 point function, and get other resonance terms. We get formulas like this for other terms, resonance terms in our action. Again, we can use in such a way to delete all unwanted 3-point correlation functions, and then we can, after this, we can compare compare the result for non-vanishing correlation function. We get this formula for 3-point function, for normalized 3-point function. In this case, we have this formula for in minimal Liouville gravity approach, and we can get a formula for the same. We get the same formula for in this approach, in Douglas approach. Then we do it the same for 4-point function, and we get some very simple explicit formula, which is written here for 4-point function. And again, it coincides with the result of direct correlation Zamolodchikov mine. And at last, we can formulate the general result for this series in terms of the former language, Legendre polynomials. It is a conjectural statement. A partition function for this series is equal to this integral. X star is solution is root of this polynomial, and y is this series. Here we have Legendre polynomials of this order, differentiated n-1 times, and it gives the answers for. It would be interesting to prove this formula. It's conjecture. It's very simple. I don't know how to do it, and I have to again to finish. The same can be partly repeated for the next series. We have, due to connection with Frobenius structure, this formula for generating function, and again we arrive to the following results: to compute 1 and 2-point unwanted correlators, we can choose in special way the resonance change for this order. It's done. It's performed in terms of, again, of Jacobi polynomials. In the case of Lee-Yang case series, it was in terms of these polynomials. In next case, this polynomial. And for 3-point and 4-point, we can, in the cases when 3 and 4-point correlators are not equal 0, we can result which coincide with honest direct computation. But there is some open problem that I will skip.
Thank you very much. Other questions?
I have somewhat naive question. Long ago, there was the following picture of which we had of this minimal gravity, etc. We said that in conformal field theory, we have primary operators, we have secondary operators, and we interpret secondary operators as deformation, as holomorphic deformations of primary operators. And when we couple it to gravity, these deformations become gauge artifacts, so they are not there, and we are left with algebra of primary operators, and it should be equivalent to some kind of topological field theory or matrix theory and so on. That was, and so the picture was extremely simple or maybe simplistic. So what's the modern view of this? Does it make any sense, this picture?
No, nothing happened in this direction. For me, at least.
I think it should, because it's really frustrating that we don't understand it in such simple terms. I started several times to try and always regularly failed in making this idea into something real. Okay, thank you.
Any other questions? I have a question. Is it possible to study large P limit? P goes to infinity and Q is finite.
Probably. I didn't try, but probably. Also, I mean that we considered here only very simplest cosmologies. Interesting.
Well, if there are no more questions, let's take Sasha.